Hello. Yeah, just admitted. Let me see. Hi, Rohi. Can you hear me now? Sorry, Rohi. I cannot hear you. Can you write on the chat if you are able to hear me? Okay. Okay. Unfortunately, I cannot hear you, Rohi, because of some issue. But I think it is not a problem on my side because let me just quickly check this. Yeah, I am able to. I am able to hear other sounds. I am able to hear other sounds. So there seems to be some problem with the microphone here on Zoom, or might be it is an issue with Zoom. Okay, no problem. Let me continue. Rohit, let's communicate on chat. Is that fine? No, no, I cannot hear you, Rohit. No, I can't hear. Let me just mute and unmute. Hello? No, Rohit. I cannot hear you. There is some issue on with the microphone, it seems. Which should not be an issue. Let's continue on chat. I mean, we can communicate on chat, right? So I'll share my screen, and then if you have any questions, right, you can raise your hand, and then we can discuss on chat. Yeah. Okay. Let me just quickly see. Yeah. I hope you can see my screen. So what we are going to do today, until the last session, what we did, we created our first decision tree. We took a small um, uh, set of the data, and we were able to set the decision tree, and we used also a parameter, and we were going through each and every of the parameters. So let me just open that page once more. Sklearn decision tree classifier. I'll just go through the parameters once, and then we are going to go ahead and we are going to look into what we can do to improve the model using these parameters. And then I'm also going to explain you some of the concepts related to what we are going to do to find out the best, let's say, parameters. Okay. So uh, we have looked into criterion. We have skipped splitter, or we just touched based on the splitter. We'll come back to splitter later on. But max depth and criterion is very important. In the criterion, entropy we know, Gini we don't know. Okay, the Gini is something that we will have to see. We'll have to learn what is Gini. You will just come to know about it when I explain it. Gini is just a simplified version of entropy, right? Or maybe I can quickly explain Gini first. So what happens in case of, let's say, Gini is that Gini index or the Gini value, okay, is where what we do is that in case of entropy, right? In case of entropy, what did we do? We took the probability, and then we multiplied it log base 2 of the probability. This is for the positive class, right? And then we did a minus sign, and then we said q log base 2 of q, right? And the assumption is p is the positive class, right? P is the positive class, right? And q is actually the negative class, or in other words, in probability terminology, p is q is 1 minus p is 1 minus q, right? So this is 1 minus q. So this is the representation, or this is the formulation of entropy. Now this I have to repeat for all of the key parameters, right? So I have to repeat for all of the parameters which I have, right? If you remember the example which we took with the play or not play thing, which we did on Excel, we did this for all of the features, right? So we do a summation until k, right? We do a summation until k, right? And we find out the entropy, right? The opposite of entropy, or the contradictory to entropy, was information gain, right? The information gain is where we say that wherever I have maximum information gain, that helps me to do what? That helps me to break, right? That helps me to break the root node, or also to select the root node. So first of all, I'll select the root node. Then I will be breaking it basis the entropy, right? So information again helps me to select the root node, right? Now what we need to look at is, give me 1 minute, give me 1 minute. Okay. So what we need to look at is just another way to calculate impurity, because entropy was basically a measure of what? Impurity, right? So another measure of impurity is Gini, right? Now Gini index, okay, Gini index, what it does is it is an index or a number which gives you the indicator or the indication of homogeneity, right? So homogeneity means if let's say I have a basket, clearly, I mean, is the same thing which we saw earlier also. Let's say I have two baskets and I have crosses over here and I have balls over here. Okay, then I can say that both of these baskets B1 and B2 are actually homogeneous within each other, because in each other's scope, they are pure. They contain only one kind of thing, right? They contain only one kind of the material, right? So keeping that in mind, it is very clear that we have homogeneous boxes, but real life is not going to be like that, right? So real life is going to be something like this. So if let's say I have a box which are two boxes which are like this. So I have more of crosses on the B1 and only couple of instances of the balls in B1. So B1 has a higher homogeneity as compared to B2, because if you look at B2 clearly, I have four crosses and three balls, right? Where, or let's say I have four crosses and four balls. So this is like a very heterogeneous kind of a bag, right? Now, Gini or entropy are just the measure, how much impure they are. Entropy we calculate it in the same way we can also calculate Gini index. So when we calculate Gini index, right? When we calculate the Gini index, we look only at the probability of one class, right? We take the value of only one out of these. Let's say we are concentrating only on the positive outcome. So let's say my use case is like, I would like to find out, my classification use case is, I would like to find out or which of my, let's say, patients who have come for the diagnosis really have a cancer or not. And I have given them labels as 1 and 0 in my data. Okay. And 1 means I have a cancer, right? 1 means I have a cancer, and 0 means I don't have cancer. Okay, this notation is actually related to probability. So if you are going to read papers or PDFs later on, right, you will see that positive classes are represented like, let's say, C, and negative classes will be represented like a sign like this bar, and then right. So C and not of C. So cancer is represented by 1 in my data, and 0 is what represents no cancer. If I have represented 1 as cancer, then I take 1 as the value, the class, right, which I'm more interested into, because I am not interested most specifically to people who don't have cancer. My intention might well be to find people who have cancer so that I can rectify it, right? I don't want to look at people, let's say, who don't have cancer. Who don't have cancer, that's fine with me. Now, keeping this in mind, Gini works very well in this case, because in Gini, what I do, I take a summation, okay, from all the values that I have until k, or for all the features k, and I simply calculate the probability square, right? Okay, I calculate the probability square. Now, this value is really very difficult to understand. What is probability square, right? So, probability square is nothing but this p over here, okay, will now not be called as, let's say, probability. It will be called the proportion. Okay? So rather than calling it the probability, I'm going to call it the proportion. That is what differentiates Gini index from entropy, because in entropy, I was dealing with the probability. Okay, I was also dealing with the quotient here also. So if you look at how I defined, if you remember how I defined P and Q, you download the Excel from our LMS also, you will see P and Q I had defined using a proportion thing also, right? So I took the number of values which I'm interested in divided by the total number of values. That is kind of a proportion. In the same way, this is also a proportion, but now I am interested in one kind of proportion. I'm taking a square of that. If I take a square of that, if I take a square of the proportion, okay, and then I continue doing the division, I continue doing the calculation. Okay, I continue doing the calculation. I come to know which split has higher Gini index or which split has lower Gini index. In other words, for each and every split which I make with feature 1 or feature 2 or feature X, which feature will give me a better value of Gini index, right? Which feature is going to give me a better value of Gini index. Now, Gini index is actually the opposite of entropy. Entropy was the negative kind of thing, right? So entropy was something I was trying to avoid, and Gini is like the positive kind of thing. Okay, so Gini, the value, if it is more, right? Gini being a value, if it is more, then it is good for us. So that's why this value, okay, of Gini index actually lies in the range of 0 to 1. So it's like a proper probabilistic value which lies between 0 and 1. Its output is not a probability, it's just an output of calculated proportions that I've done. But ultimately, they result, okay, ultimately the value will result into some value, okay. If I calculate, let's say, the Gini index for one of the splits which we did on, let's say, whether it is going to rain or not, right? Whether it is overcast or not, or whether the temperature is high, medium, or low or not, right? Then what it is going to do, it is going to give me a value which is my Gini index. I do the calculation using the formula. It gives me the Gini index which falls in the range 0 to 1. If it is closer to 0, okay, more it is closer to 0, I say the impurity is more. More it is closer to 1, I say the purity is more, right? So that is how I decide. That is the second difference, you can say, between entropy and Gini. And that is one of the primary reasons why sklearn, okay, scikit-learn uses Gini index as the primary method of finding out the valuation. Because now, if I only calculate the Gini index and I get a positive value, do I really need to calculate the information gain? Yes, I may want to calculate it only for the root node. Or maybe I can even skip that. Now information gain has become optional for me. If I have got a value of Gini index, I can blindly say that Gini index, I'm not saying Gini index is better than entropy. Each of them have their own pros and cons. Okay. If you look at it from a very technical perspective, or from a very authentic, or let's say from a very pragmatic kind of a perspective, it's quite clear if I'm defining impurity, I should give it by a number which is actually a negative number, right? So it means, well, it forms a good structure if that number is a negative value, right? Lower the number or higher the impurity, that's I can say. Now, here it is more practical, right? Gini index, that number is actually more practical. Here, higher the Gini index, lower the impurity, right? So, uh, this value is actually more relatable, right? So that's the reason why sklearn uses it. But we have to find out, okay, basis our use case, we have to find out which one is going to work best. So we have to select the best one. That's what exactly we are going to do. I hope it is clear. I'll also share a few materials extra which you can look at. The next one was splitter. We're not going to look at it right now. We're going to look at it max depth, mean sample split, mean samples leaf, and so on. So I'm going to go through a few of them, right? So max depth is the maximum depth until the tree can go, right? Mean sample split, okay, is the number of samples, okay, the number of samples which should be there in a node, okay, so that I can break. For example, I am creating a tree and I am gone to level 2, and in level 2 I have a node which has only 10 samples which are left out which with only 10 observations. Should I create a split there or no? Out of 10 observations, is it really practical to create a split or no? Maybe it will be better if I don't keep a or if I don't create a node there, if I don't create another grade there, another branch there. Instead, if I had 100 samples, I could have divided it into 60-40 or 50-50 kind of thing, right? That would have actually been better, right? That would have actually been better, right? But we don't know. We have to see which one really works for us, okay? Which one really works for us. But the thing that we need to remember over here is that the minimum number of samples required to be at the leaf node, right? That's the uh, uh, um, sorry, we were looking into sample split. I'm sorry. So minimum number of samples required to split an internal node, right? If it is an integer, then consider minimum sample as the minimum number. If it is float, then it is simply a fraction. Okay, but you can ignore this statement right now. It is only going to confuse you later on when you do more and more use cases, right? You'll come to know how this really falls into place. But as of now, simply remember what is going to be the breaking criteria other than the impurity of that node, right? Other than the impurity of that node, what else are we going to use? Is this kind of variables which we have. Then I have min samples leaf. So how many samples should be there in leaf. If I'm going to call a node a leaf node, it should have at least 10 or 20 samples. So for example, leaf node is where I make the actual prediction. I should not be making a prediction only for a handful of rows. Then what will happen? I'll have a lot of leaf nodes, right? I'll have a lot of leaf nodes. So clearly you can see max depth and mean samples leaf are logically related to each other. If I have large depth, right? If I have large depth, then I'll have small mean sample sleeve and vice versa, right? If I have smaller depth, right, minimum sample sleeve is going to be a handsome number or a manageable number, right? Then the most important feature is also max features. How many features am I going to use? Okay. If I'm going to look for a split and I have multiple features, okay, am I going to consider only one feature like the example which I took on my Excel sheet when I tried to say whether I'm going to play or not? In that case, I took only one feature, right? If you remember, for each and every node split, I used only one feature. I can use multiple features also. I can use multiple features to break one node also. And then I can break down, I can break down, I can break down, and so on and so forth, right? So the default is none, which means I'm not going to consider that. In a sense, if you come back to our diagram, you see that each and every node is actually broken by one only. It is broken by one, then another one, then another one, then another one, and so on, right? So this kind of breaking is done for each and every node. If you look at the diagram, I am breaking it basis only one. Okay, here I have samples, here I have one, here I have education num, right? Education num is there, and then I'm calculating the gain index, then I'm making a break. Then on another one, here it is actually capital gain. I'm actually making a break again on education num, right? And so on. So usually or by default it is none, which means I don't want multiple features to be considered in this case, right? But we will see which one is really going to help us, right? So what we are going to do now is we are going to study a concept which is called cross validation, and then we will use that concept of cross validation. Okay, we will use that concept of cross validation to find out better, let's say, parameters. So let me just quickly set the stage by going back to my notebook, and I'm going to say from sklearn, okay, model selection import. I think Likit is trying to enter also. Let me allow him. So from sklearn model selection, I'll import K fold. I'll explain why or what I'm doing. Okay. sklearn dot model selection. I'm going to also import grid search CV. Okay. Please ignore the names now. I'm going to explain how they work and then only we are going to. Now, what we have to do, or what we should ideally do, is that you see we have a lot of, let's say, parameters. These parameters are also known as the hyperparameters. These hyperparameters, each and every one of those hyperparameters can actually take multiple values. So let's say I want to find the best value for a criterion, as well as for splitter, as well as for max depth, as well as for mean split, and so on, right? So in that case, I'll have it's a permutation combination kind of thing comes into play over here, and I will eventually have to fit those many number of models, okay, those many number of models to find out the best a combination of the parameters, right? I have to find out the best possible combination of the parameters by manually creating the models. So let's say I create one model with criterion equal to Guinea, everything is set to default. Then I create another one with criterion equal to entropy, everything set to default. Then I leave criterion equal to Guinea, set splitter equal to best, everything else to default, and so on and so forth, right? Now, if I do this, I can do that, right? I can write a function and I can reuse the function. I can really do that. I can write it into Python. I can write it as a function. I will simply pass the parameters, right? I'll continue passing the parameters and over again in different cells. Or maybe I'm going to loop through. I'm going to create a for loop, call the function inside the for loop to create the model, to fit the model with different combinations of these hyperparameters. I can do that, but that's not going to be programmatically friendly, right? Because I have to first of all write a lot of code, and hence I'll have to maintain it. So what I do, I use a methodology known as k-fold cross validation. I hope you can see the diagram, right? Let me just open image in new tab. I'll just open the image. What I'm doing over here, this is the idea. This is not what I'm actually going to do. This is just the idea. I'm just sharing the idea. What I'm actually going to do is going to be a bit, let's say, different. Okay, it's going to be a bit, let's say, different. What I will do is that I will first of all select how many folds I want or how many iterations I'm going to do. I'm going to select a random number. Let's say I'm going to do folds n is equal to 5. What do I mean by folds n is equal to 5? Which means I have, let's say, a data set which has total 200 observations or 2000 observations or 20,000 observations. I'll take all the observations and run my experiment 5 times. Run my experiments 5 times. How am I going to do that? Now you will come to know that k-fold not only helps you to find the most effective uh, estimator which we need to use, it will also help you to formulate what is known as grid search cross validation. In k-fold, or the idea of k-fold is that I take, let's say, in each and every set of data, in each and every fold, I have the entire set of data. I take 15% or 20% of my data as a testing data. The rest 75 to 80% as the training data. And I fit my model, right? I fit my model on the training data, see how it is going on to the testing data. Then I do the same thing on another fold, but now I select a different set of testing data.
Sir,
Yeah,
sir,
Heliket, go ahead. Yeah.
sir, means the test data means what will be doing with the test data, sir? Generally,
So we will be breaking it. So if let's say this is my entire data and I have, let's say, 20,000 rows, and I'm saying 10% is test data, which means randomly, okay, randomly, I'm going to select 10% of these rows and I'm going to keep it aside. Okay, so let's say this is the 10%, I have kept it aside. Okay, on the rest 90%, which I have not kept aside, I will build the model. I will build the model and I will test it on the 10% of data. So the model learns the parameters or the pattern in the data from the 90% of data, and then it tests the outcomes, whether it has really learned it or not on the 10% of data. The other way to understand this is, let's say I have 100 questions in my book. I have a physics book. I have 100 questions. I take out 20 questions randomly and I don't look at it. Okay. I practice the rest 80 questions. I practice the rest 80 questions. I believe now I remember all the formulas, all the ways, all the tactics, and so on. Now I want to test myself. So I close my book, I go to a different room, I give myself an exam. I sit for an exam with these 20 questions. And let's see how many I score correctly. Right? So this is how we divide each each fold of the data into training and testing.
okay, sir. Thank you, sir.
Okay. Now in k-fold, what we're doing now, if you just try to remember this, if I just take only this one, okay? Take only one of the iterations over here, we were already doing this. We are using train test split function to create the test set, create the training set, feed the model over here, then you test the model over here. We are already doing that. Then what is the advantage of using k-fold? K-fold is saying you do it for n number of times or k number of times. K is the number of folds, and for each and every fold you randomly or you change the test data. So if this is the test data in my first fold, in the next fold, the test data is going to have different observations. In the next fold, test data will have, let's say, different observations and so on and so forth. In this way, I learn more patterns within the data, right? I learn more patterns within the data. Now, where does my parameters come into picture? That is my question. I was looking into the parameters, right? I am more interested in the parameters to find the best, let's say, parameters. This is where grid search cross validation comes into place. Okay, grid search cross validation is going to come into place. What I'm going to do, I'll open this image in a new page. And here what we see is in the first iteration, we take one setup. Okay, we take one set of, I will call this a set one. I take one set of hyperparameters. Okay, I have put all the parameters in this set. Okay, P1, P2, P3, P4, these are all my parameters, the ones which we saw in the documentation, right? I take one set, I am going to take that set and test for this fold, right? For the first fold, I'm going to test with these or the combination of those. Then for the next fold, I'm changing the testing data and taking a different set. Okay, I'm actually taking a different set, but if I do that, there will be a problem. It means for each and every fold, I will be testing different hyperparameters, right? Instead, what I do or what sklearn library will do or any production ready library should do is that for all the kth iterations, here I have 10 folds or k folds. k is equal to 10. For all the iterations, I select one set. I select one set of hyperparameters, right? I select one set of hyperparameters where I give,
Sir, hyperparameters means the features of the models, right, sir?
no, no. The hyperparameters are these, the ones that I was actually talking about in the beginning of the class. So these are like criterion will be what, max depth will be how much, mean sample split will be how much, mean sample leaf will be how much, and so on, right? So I take one set of any value. Let's say in set one, my criterion I have set equal to Guinea, splitter I have set equal to best, max depth I have set equal to 5, mean sample split I have set equal to 10, mean sample leaf I have set equal to 20. That becomes my set one. Now what I do, I apply the set one on all the iterations, right? I apply that set one on all the iterations. I build 10 models and I find out what is the approximation or the average accuracy of my model, right? So I get accuracy one. I get accuracy one for set one. Now I find accuracy two. I find accuracy two for set two by creating a new set. Now I'm going to change the values of P1, P2, P3, create a new set, run again these 10 iterations and find accuracy 2. In this way, I'm going to take n number of combinations, n number of sets, S1, S2, S3 until Sn, and I'm going to fit them on all the 10 iterations, which means if I have 10 sets of hyperparameters and I have value k equal to 10, then I have 100 iterations of the model. I have fit the model 100 times. 100 times I fit the model only to get that correct set, only to find out which set, let's say S4, okay, let's say S4 is the best set I find. Why? How? Because let's say for S4, the accuracy A4 was the highest among all the 100 fits, right? Among all the 100 fits, A4 was highest or A4 was the best, right? With combination S4, right? That's exactly what we are going to do using grid search. Now, yes, if I have understood the algorithm, I can write the program. It's not an issue. I can write the program. It is just a program. I just have to loop through. That's all I have to do. But I'm not going to do that. The reason being, these libraries which are there in Python, they are already written in low-level languages like C, C++. I'm not going to waste my time. Okay, I'm not going to waste my time. I simply call these functions. These functions are extremely fast in the backend. I simply define the parameters. I will simply define the I will be simply defining the parameters. I'm going to define the depth, right? I'm going to define the number of folds, I'm sorry, number of iterations which I'm going to have. And then it is itself going to run. And it is going to itself tell me, okay, I have run 100 tests. I have fit 100 models. This is what I get. How do I get that? Let's see. Okay. Once you see the implementation, you will come to know what we are doing over here. So let's write some code. So what we are going to do, I'm going to call a variable. I'm going to create a variable called parameter grid. And this grid is going to be a dictionary. In the dictionary, I'll take four of my favorite hyperparameters. One is max depth. I'm going to give it a value of range 5 until 15 with a gap of 5. We have seen the range function in Python. From 5 until 15 with a gap of 5, it is going to select max depth. It means I am selecting three values, 5, 10, and 15, right? Then I will select mean samples leaf. How many minimum number of samples should be there in a leaf? I say range 50, let's say, to 150 with a gap of, let's say, 50, right? Then I will take my third one, which is going to be, let's say, mean samples split, right? Mean samples split. This is going to be a range of, let's say, I'll just take the same range just to make things simpler. I'll take the same range. Usually, we don't take ranges like this. We take even bigger ranges. So for max depth, we'll take ranges like 1, 5, 10, 15, 20, 25, and so on. But that will require very good computing power. I don't have that kind of a laptop. So I'm just going to restrict my self, right? I'm just going to restrict to myself with this. And I'm going to do criterion, okay, criterion, and I'm going to select, let's say criterion, I know I can have only true values, entropy, and I can have the other one is Guinea. right? So I just write it as a list. I know I can have.
Sir, entropy spelling py sir, not
Oh,
phy. I think so, sir.
yeah. Let me just cross check. I think you are right. Yes, entropy. Yes, right. Thank you. So it is this. Okay. So I've just selected four of the parameters. You can select n number. You can select all of them. I've just selected four of the ones which, basis my experience, I find them to be really useful while calculating. Okay, while calculating the best accuracy of the model. Right. Now what I will do. Okay. Now what I am going to do is that I'm going to create a new decision tree. Let's say D tree, which I'm creating using cross validation. So I'll name it as DT underscore CV. Okay, I'm going to call decision tree classifier. Okay, so this DT underscore CV is basically a decision tree classifier. I'm not passing any parameters here. See, I have not passed any parameters there. I don't want to pass any of these parameter values over there. Okay, how am I going to pass them? I'm going to create a variable called grid search. And in that grid search will basically be an object of grid search CV. And here, what we are going to do, okay, here to what we are going to do is that I'm going to say want to pass the parameters over here. Okay, so my estimator or my uh, model is going to be dt underscore cv, right? My estimator or my model is going to be dt underscore cv, the one that I have created over here in the last line. Then I will say my parameter grid. Okay, the variable is also called a param grid. Okay, so the parameter grid is going to be the param grid that I have created over here, right? Then I say, right? Then I say how many folds I would like to run. So CV or cross of validations is equal to the number of folds I want. Let's say I want 5 folds, right? And I'll use a, a variable. This is an optional one. The verbose is equal to 1. Using verbose is equal to 1, it goes into depth and does not stop even if it faces any warnings. Okay, so verbose is like it is really going in depth of each and every model, right? So I just want the outcome to be verbose, right? So I create a variable. You see, it has not executed anything. It will take time. Okay, I've just created a variable. Now what I do a grid search dot fit, right? I do a grid search dot fit, and I use my training data extend vital, right? The moment I fit my training data, okay, the moment I fit my training data, I will get the variables. Now you might be wondering, let's go back. Let's go back to the diagram. Let's go back to the diagram. Now here we said I'll take all the observations, right? I said I'll take all the observations and I will break it into training and testing data, then I'll pass. Which means for each and every grade or for each and every iteration in that grid, I will pass both the testing and the training data. That is not what I'm going to do. Why? Because that is not what we usually do. Okay, that is not what we usually do in the industry. In the industry, what we do, okay, in the industry, what we do is that we take only the training data and apply this technique. We don't touch the testing data at all. So let's say I have 100 rows and my testing data is, let's say, 20%. So 20 rows I have already kept aside. The remaining is what, 80. So I'll take only 80 and apply this technique. I'll take only 80 and apply this technique. How? For each and every validation, for each and every validation, I'm not breaking the data into training and testing set. I'm instead taking only the training data and fitting all the parameters. Okay. And I'm seeing which model is going to be the best. Then later on, once I found out the best, let's say, parameter set, let's say S4, which has highest accuracy, A4, then I take A4 and I'm going to put it on my testing data and I'm going to see how it is going to perform. Right. Now I'm going to run this. This is going to take time. Right. This is going to take time. Once it is done, okay, once it is done, then we are going to look at the parameters which I get. So let me just run this. So now what it is doing? I have three values here, three values here, three values here, and two values here. So three, 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 and two. Okay, it took along with five and it has fit 80 fits. So it has actually fit 80 models. When I say totaling 80 fits, it means it has fit 80 models. And now I'm going to say, you give me grid search. Okay. You first of all, you tell me what is my best estimator. Okay. Tell me what is my best estimator. It says if I use max depth 10, mean sample split 100, mean sample split equal to 50, right? Then this is my best estimator. It has not taken into consideration criterion at all. So it is saying that you don't have to consider criterion at all. You forget the criterion, take only these three variables, you will get a very good model. Now, what does it mean by good model? Right? What does it mean by good model? If I just take grid search and call best score, right? I get a best score of 84.97, which means if I create a model, if I create a decision tree model with these three hyperparameters, I should get a model which has close to, not exact, close to 85% of accuracy. Let's see. L- l- let's see. So I'm going to call this ET final. So my final decision tree classifier using cross validation that I have done, I'm just going to put it over here, right? And then I'm going to create the model, right? I'm going to create the model and see how it goes. So I create the model. Now what I have to do, dt final, I'm going to fit extend y10, right? Okay, dt final dot fit. I'm sorry, right? I have hit the model with the best estimator or the best parameters, the sample set, right? The a set, the set of the best combination of hyper parameters I have set over here, right? And then uh, give me 1 minute. Give me 1 minute. Okay. Now what I'm going to do, let's say y pred final is equal to dt final x test. So I'm taking the predictions. So to do that, I'm going to call the predict function. Now I have got the final predictions using the test data. Now I want to know classification report. Sorry, I have not imported that. So from sklearn dot metrics import classification report and accuracy score, right? And then what I'm going to do, print classification report with y test and print classification report with y test and y pred final, right? Now I get a model which is actually my best model basis the kind of data that I have, basis the kind of hyper parameters that I have used, and this is the model I get, right? So this is the model that I get, right? If I fit the model, I get this, right? The model is not bad. I have quite a good balance between precision and recall, right? I have quite a good balance between precision and recall. Let me see what is my accuracy score. So what I'm going to do, I'm going to take this and let's say what I'm going to do, let me just copy the entire cell. Okay, I'm just going to change the function, right? So I'm going to call accuracy score and I get an accuracy of 84%, right? I get an accuracy of close to 85%. I mean, if I round this, it will be 85, right? Let's see if this has helped us give better model or not. So if I come up, I'll go up and see what was uh, the accuracy which I had earlier. The accuracy which I had earlier, it was like 84.11, right? It was closer to 84.11 with max depth equal to 5. I randomly chose earlier max depth equal to 5. Accuracy is equal to 84.11. And now my model accuracy is 84.76. It's a very small increase. 84 to 85% only we have increased. But the reason why this gives us good amount of, let's say, confidence, okay, is because we have cross validated the results, right? Because we have cross validated the results, we get better results, or we can guarantee, or we can say that we are actually getting better results, right? We are getting better results because I have not blindly selected the default values, right? I have not blindly selected the default values. I have selected the ones, okay? I have selected the values of the parameters or the hyperparameters, I'm sorry, which the combination of which gives me the best model, which is really possible, right? Without writing much code, I have done this, right? So this is what I wanted to show you, right? This is what we usually do before, I mean, we really decide, right? I mean, we do this even before we finalize the model. I mean, we do this for each and every module. So what we are going to do now is that because of some other work, we may have to close early today. So we will be closing within 2 minutes. If you have any questions, we can discuss that now, and then we can close. But when we continue from the next sessions onward, wherever we do, okay, wherever we do any kind of, it's a modeling, okay, wherever we do any kind of classification modeling, especially, okay, I will always use, okay, I will always use this method to find the combination of the best hyperparameters, so that I can be sure that even if the selection of the hyperparameters are the ones which are really the default value. For example, in this case also, if you see the parameters that I have selected, I did not select the criterion, right? I have not selected the criterion because my grid search told me criterion you don't need. It can be of any value. Now, if I go back to the documentation itself, by default, it is Guinea, which means this model that I have fit, the final model that I fit, right? It uses criterion is equal to Guinea, right? Uses criterion is equal to Guinea, right? So it is actually using the default value of one of the hyperparameters. Still, I am getting a best result. So I just want to create some confusion as well as clear some confusion by stating, by clearly stating that the reason why we are doing this exercise is not to override the default values. By doing this exercise, we may also get output as the default value. But still, as a data scientist, we need to confirm. We need to confirm exactly what we need to do or exactly which parameters we need to use. And then only we should finalize my model. Else we should not, right? That's the reason why we did this, right? Unfortunately, friends, I'll have to close the call because I have some other meeting to join. I just realized that I'm already 2 minutes late. But are there any questions? Maybe we can go through the questions and then we can end.
Sir.
Yeah.
Actually, I'm facing issue in joining that accessing the Canvas recorder session, sir.
Okay. So
It's asking the join code for the Canvas, sir. I don't know how it is done.
no, but have you received a mail?
Yeah, I received the mail.
Uh-huh.
Actually, the Canvas previously I created an account. Actually, regarding our class and all those things, but I
Mhm.
have to join your class, right? It's asking the join code, sir. Now, what's the join code for the class?
Okay. Usually that should not happen. Let me just check if there is any issue. Okay, let me just check. Okay, let me log in. I'll offline check this and maybe I'll send you the join code if there is any such option to send you the join code.
Okay, sir. Okay, sir. Okay.
Okay,
Thank you, sir.
right? Usually that is not the case because the rest of us have directly joined using the link, right? Usually you should not ask any join code, right?
Yes,
Because
sir. I am quite new for the Canvas and all those
yeah,
things.
no problem, no
That's
problem.
why.
That's
Okay,
fine.
sir.
That's fine. Any other questions, friends? Sarang, Surohi?
No, Bobby, not from me.
Okay. Sarang, he maybe you can type on chat because I may still not be able to hear you. So if you can just quickly write on chat if you have any questions. No. Okay. Okay, friends. So tomorrow there will be no session because I'm actually traveling. So I don't know at what time I'm going to reach and what is going to be the situation back home. So most probably tomorrow we will skip the class. We'll start from let's say Monday again. Yeah. Okay. Thanks all.
Yeah, Bobby. Have a safe journey. Bye
Thank you,
bye.
sir.
Thank you for joining. Thank you, Sarang. Thank you. Thank you.